Space, the final frontier. It has captivated humanity for centuries. We look up at the night sky and wonder, what's out there? Rockets are our vessels to the cosmos. These incredible machines carry our dreams and ambitions. But how do they actually work? Get ready for liftoff. At the core of every rocket lies its engine, a marvel of controlled combustion. Imagine a giant fire-breathing dragon, except instead of fire, it expels scorching hot gas. This gas is the engine's exhaust, and it holds the key to defying gravity. The engine itself comprises several crucial components, each playing a vital role in generating thrust. First, we have the combustion chamber, where the magic happens. Here, fuel and an oxidizer, often liquid oxygen, mix and ignite in a continuous explosion. Next comes the nozzle, a carefully shaped cone that directs the flow of exhaust gases. The nozzle's design is crucial. It accelerates the hot gas, squeezing it through a narrow opening to increase its velocity. This high-speed exhaust is what propels the rocket skyward. We can't forget the pumps. These workhorses draw massive amounts of fuel and oxidizer from the tanks and feed them into the combustion chamber at incredible rates. The pumps themselves are driven by turbines, which in turn are powered by a small portion of the rocket's fuel. Constructing a rocket engine is no easy feat. It demands materials capable of withstanding extreme temperatures, pressures, and vibrations. Imagine the heat of the sun, the force of a hurricane, and the shaking of an earthquake, all happening at once. One of the most common materials used is a superalloy called Inconel. This nickel-chromium-based metal can handle the intense heat generated within the combustion chamber without melting or warping. It's like giving the engine a suit of armor forged in a star's heart. For the nozzle, where temperatures are even higher, engineers often turn to carbon-carbon composites. These materials are incredibly strong and lightweight, capable of withstanding the scorching blast of exhaust gases. Think of them as the rocket's heat shield, protecting it from the inferno within. Other exotic materials, such as titanium and specialized ceramics, find their place in various engine components. Each material is carefully chosen for its unique properties, ensuring the engine can endure the rigors of launch and spaceflight. Building a rocket engine is a meticulous process, a testament to human ingenuity and precision. It begins with the tiniest components, painstakingly crafted and inspected to ensure flawless performance. Imagine technicians in clean rooms, meticulously assembling delicate valves and injectors, their every move precise and deliberate. These components control the flow of fuel and oxidizer, ensuring the engine operates at peak efficiency. Larger components, like the combustion chamber and nozzle, are often manufactured separately and then carefully joined together. This process requires specialized welding techniques and rigorous testing to guarantee the integrity of the joints. Finally, the completed engine undergoes a battery of tests. It's subjected to simulated launch conditions, extreme temperatures, and vibrations to ensure it can withstand the stresses of spaceflight. Only then is it deemed ready for integration with the rest of the rocket. The science of controlled explosions. Now let's talk about how this incredible machine actually works. At its heart, a rocket engine is a controlled explosion, but instead of unleashing all its energy at once, it channels that power into a continuous stream of thrust. It all starts with the fuel and the oxidizer. Think of them as the two ingredients needed for a spectacular fireworks display. The fuel, often liquid hydrogen or kerosene, provides the energy, while the oxidizer, usually liquid oxygen, allows the fuel to burn fiercely. When these two components mix inside the combustion chamber, they ignite in a continuous explosion. This combustion produces a tremendous amount of hot gas, which expands rapidly and searches for an escape route. That's where the nozzle comes in, acting like a funnel that channels and accelerates the expanding gas. As the gas is forced through the nozzle's narrowing throat, its velocity increases dramatically. This high-speed exhaust is what generates thrust, propelling the rocket upward. How can a rocket propel itself in the vacuum of space? There's nothing to push against, right? Newton's third law. For every action, there is an equal and opposite reaction. Throw a ball forward and you roll backward. The same principle applies to rockets. Expelling hot gas creates an equal and opposite reaction, propelling the rocket. In space, there's no air resistance, making thrust efficient, thanks to Newton's third law. Escaping Earth's gravitational pull is no easy task. It requires immense power and speed, which is why rockets are such incredible feats of engineering. To break free from Earth's grasp, a rocket needs to achieve a speed called escape velocity. Imagine yourself throwing a ball straight up in the air. The harder you throw it, the higher it goes before gravity pulls it back down. Escape velocity is like throwing that ball so hard that it never comes back down. For Earth, escape velocity is about 7 miles per second, or over 25,000 miles per hour. To achieve this incredible speed, rockets need to carry a tremendous amount of fuel, which makes up a significant portion of their total weight. As the rocket ascends, it constantly battles against gravity, which is always trying to pull it back down. But as the rocket burns fuel and sheds weight, it becomes easier to accelerate, eventually reaching the speed needed to break free from Earth's gravitational pull. While chemical rockets have served us well, scientists are searching for more efficient ways to propel spacecraft. One promising technology is the ion drive. Ion drives use electricity to accelerate ions, creating thrust. These engines are far more fuel efficient. Imagine a car traveling to the moon on a single tank of gas. That's the efficiency ion drives offer. They can operate for years, gradually accelerating to incredible speeds. Other concepts, like nuclear fusion and antimatter propulsion, are also being explored. These technologies could revolutionize space travel, allowing us to venture farther and faster. The development of rocket technology has had a profound impact on society, extending far beyond the realm of space exploration. From telecommunications satellites that connect us globally to weather satellites that provide early warning of natural disasters, rockets have become an indispensable part of modern life. But perhaps the most significant impact of rocketry is its ability to inspire generations to dream big and reach for the stars. The images of humans walking on the moon, the stunning photographs from the Hubble Space Telescope, these achievements ignite our imaginations and push the boundaries of what's possible. When we invest in space exploration, we invest in our future. We foster innovation, push the limits of technology, and inspire the next generation of scientists, engineers, and explorers. The pursuit of knowledge and understanding is in our nature, and rocketry provides a powerful tool for unlocking the secrets of the universe. If you liked this video, give it a thumbs up and share it with your friends. Also, subscribe to this channel and hit the notification bell to keep learning. See you in the next video.